We're supposed to solve this one for when the parabola is greater than 0. Since this is a right side up parabola, if we find the two x-intercepts, that's when it would be equal to 0. And when it's greater would be these tails out here, so it would be greater than this x value, and for x is lower than this x value. So I got to find these two x-intercepts, which is what the quadratic formula does, or factoring does. Quadratic formula says the opposite of b, plus or minus the square root of b squared, minus 4 times minus 4 is minus 16, times 3 is minus 4 times minus 4, because it's minus 4 AC, minus 4 times minus 4 is plus 16, times 3 is plus 48, all over 2a. 48 plus 16 is 54. 64. Square root of 64 is 8. Negative 4 plus 8 is 4/6 or 2/3. That's one of these. We're not sure which one yet. The other one is negative 4 minus 8, which is negative 12/6, which is negative 2. So the negative 2 one must be here, and the 2/3 must be here, because this one's the positive and that's negative, or bigger than that one. So this section, where this is greater than or equal to 0, would be from negative infinity up to negative 2, and including negative 2 because it's equal to 0, or from 2/3 to infinity. This portion is where the parabola is greater than 0. And again, I could have got this by these two by factoring. 3x, and it would have to be x, and a minus 4 could be 2 and 2 or 1 and 4, either way. And so I'll start with 2. This would make 6, and this would make 2, which would be 4 if they were subtracted, and it says they are. I have to come up with negative 4, so one of these has got to be negative. I want positive 4, so that'd be positive 6 minus 2. Excuse me. So we set 3x minus 2 equal to 0. Add 2, divide by 3, we get x equals 2/3. That matches this one. And x plus 2 equal to 0 means x equals negative 2 when we subtract 2 from both sides, which is that one. The number of items sold, x, depends on the price, p, by the item sold is equal to 100 minus 25 times the price. So this is how much are sold. Revenue is how much you bring in from selling so many items at some price. If this is the number of items you sell, you have to take that, items sold, times the price you get for those items. So we take 100 minus 25p times the price, and that would be the revenue as a function of the price. So you get 100p minus 25p squared. This is the squared term, so this is an upside down parabola, so it will have a maximum revenue at some price. We get that by minus b, and since this is the linear terms, that would be minus 100 over the quadratic term, 2 times a, so that'd be minus 50, which is 2. Assuming this is dollars, it might be $2,000 or $200 or whatever, but assuming it's $2, that's saying that we'll get the maximum revenue when the price is 2. It says what price maximizes revenue, so we'd have to say 2. And if it asked what the maximum revenue is, I'd have to put 2 into here and figure that out. I didn't, but I could. So that would be 2 times, let's see, 2 times 25 is 50. 100 minus 50 is 50 times 2 is 100. So the maximum revenue would be 100, whatever, 100,000, 100, whatever this is standing for. I could also ask for what quantity produces the maximum revenue. And so 2, you would go back and put it into here to find the quantity, because X was the number of items sold, which would have been 50. 50 items sold at $2, maximizing revenue at $100. So, but for this problem, this asks for this answer. So you have to read the question and make sure you're answering the right thing. Now, 7, we need to put this into the calculator. Stat, edit, and I have to put in 1.2, 1.5, 1.6, 1.9, 2.3, 0.5, 0.2, 3.1. I said you have to put it in the calculator. You don't really have to put it in the calculator. You just have to graph it well enough that you can tell whether it's linear or not. 3.4, 3.9, 4.3, 4.7, 5.7, 1.9, 1.5, 7.3. Now they're in list in 1 and 2, so I go to stat plot, turn number 1 on with list 1 and 2 scatter plot there. So if I graph, zoom 9 so I can see the dots, and they look pretty straight. A linear model would be decent. Looks rather straight line-ish, so we would find the linear model, and that can be done by just picking 2 points. You could have been done it manually. You could also go stat, calculate, and use median, or linear regression. Either one of those. After you say it, then you want to say, I'm going to get the x's from list 1, comma, I'm going to get the y's from list 2, comma, and if I want to see the line, I'll put it vars, y variables, have it go into the y1 and press enter. It says my linear model is 2x plus, that's really close to 1. You might have put 2.03x plus 0.968. That would also have been a good linear model of this. Either one of those. If you'd done, and the r here, r squared is telling you how well it fits. If that's not turned on in your calculator, you might not see it. If it's close to 1, which these both are, it says it fits pretty darn well. If we could take a look at it, graph, you can see it goes pretty well right down the middle of those. So there's no motivation to do this quadratic when it's that straight. Okay?